Welcome back, everybody. Our next speaker is Monica Sarbu from Elastic, and actually the first creator of the first beat, I guess?
Yes.
Yeah, she will talk about collecting the right data to monitor your infrastructure.
Can you hear me? No. I think the microphone, yeah, now works. Hi, everyone. So let's say you want to monitor your infrastructure, your services, your applications, and your containers. I think it's a bit challenging to set up a monitoring system because there are so many, there is a lot of data that you can collect, and there are so many tools out there that it's very difficult for you to know which one you will need. So this talk aims to guide you through different types of monitoring data and their use case. But before we start, I start presenting, I start talking about this, let me say a few words about myself. So I'm building monitoring tools for over 10 years now. Initially, I was working for a startup here in Berlin, doing a monitoring solution for voice over IP networks. I have a bit of an echo. Starting with like 4 years ago, I started Bit. Thanks. I started Bit that is a more generic monitoring solution. It's open source, and currently I'm working for Elastic, and I'm leading the Bits team. So I think everyone knows about Elastic. So Elastic is the company behind Elasticsearch. Let me say a few words about bits. So I'm using the bits in plural because there is not a single project. It's a family of lightweight shippers that are collecting all kinds of operational data and send them to Elasticsearch. Bits are open source. They are written in Golang. And we have a bit for each type of data it collects. For example, we have packet bit. For network data, we have metric bit that fetches metrics from different services. We have Filebit that collects the logs from your servers. And we have WinLog bit for Windows event logs, and Heartbit for uptime monitoring. We are doing a bit more than that in the sense that we are building a platform that makes it easier for our users to build their own bits. A proof is that there are over 40 community bits created. So bits can be used for multiple use cases. For example, there is application monitoring, for network monitoring, for service monitoring, for system monitoring, and even for security. I like to go next through to take one by one and tell you what data we think is important to collect for each use case. So let's start with application monitoring. I think the first thing you will do to monitor your application will be to collect the logs. So for that, you can use Filebit to collect the logs from your application. And if your application writes logs in a JSON format, then it's easy in the sense that the logs are already parsed. You don't have to do anything. But if your application doesn't write the logs in a JSON format, you have to do the parsing. So you probably have to write some grok patterns to parse the log lines that are generated by your application. And there are two ways how you can do that using the Elastic Stack. One way would be to use the ingest node plugin, which is a plugin for Elasticsearch, and the other option will be to use Logstash. And in the second case, you will have to send all the events through Logstash to Elasticsearch. Based on your logs, you can also get metrics. Imagine you have a function that is logging a line, and you can count, for example, how many times that function was called. It's true that this is an option, but it generates you quite a lot of log lines. Another approach would be to instrument your code, and this way you can get more. You can get metrics. So one option will be to use the client libraries offered by Prometheus. I think they have official support for Go, Java, Scala, Python, and so on. But they also have a bunch of others that are from community. So the way it works is that you instrument your application using these client libraries, and then they expose their custom metrics over HTTP, and then you can use MetricBit that is written by us to pull to get the metrics and then push them to Elasticsearch. If your application is written in Java, then you can use Jolokia. You can install it as an agent on your JVM, and then it gets your JMX metrics and expose them, and then you can use MetricBit to fetch them and push them to Elasticsearch. If your application is written in Go, then you can use xvar package and to instrument your code. And MetricBit, so xvar exposes some custom metrics over HTTP, and MetricBit fetches metrics from there and inserts them in Elasticsearch. So there is a Go module in MetricBit that does that. And for example, if you have a Go application that just imports the xvar package, then you will get by default some metrics about heap, garbage collector details, and things like this. So this is a dashboard. This is a Kibana dashboard that comes with this Go module in MetricBit and gives you details about the heap and the garbage collector. So if your application is running on Windows, probably you are interested in collecting the application event logs. And with that, you can use WinLogBit. It's very easy. You just have to say that you are interested in application event logs. If your application is running in Kubernetes, then you need to, in order to monitor your applications, you need to install the bit on each node. And you can enrich the event that is generated by the bit with metadata from Kubernetes pod by using a processor that is called Kubernetes. And this way you can get details about the pod name, namespace, labels. Why this is important is that this way you can basically correlate all the events that are generated by bits, like for example metrics and logs. You can correlate them with the Kubernetes pod, so you know which pod generated the logs or the metrics. If your application is running on cloud, then you can use a similar processor. It's called Add Cloud Metadata that gives you some details about the cloud. And we support a few clouds here. Is Google Cloud, Amazon Web Services, DigitalOcean, and then it's Tencent Cloud and Alibaba Cloud. Those two were a community contribution. So applications are not standalone. They usually integrate with other services, for example, with databases like MySQL, Memcache, or with key value stores like Redis, or a queuing system like Kafka. So probably you also want to monitor the services. And the first thing you probably would do is to get the logs from your service. So for most common services, Filebit has modules that gives you an out-of-the-box experience because they include everything you need to collect, parse, and visualize your logs. So in order to monitor a service, like here you can see the command line that you can use. You specify the service that you want to monitor or the list of services that you want to monitor, separated by a comma, and then you will basically instantly you will be able to have a dashboard like this one, where you can monitor, for example, in this case, you can monitor Apache. And as you can see here, you will get the logs from Apache parsed. So for example, I can see the map with the unique IPs that access that Apache, or the response code of top URLs, or the browsers that are used, or operating systems, and things like this. So all this information were extracted from the logs. Similar with Filebit modules, you can also have metric bit modules. So for most common services, like for example, Apache, Redis, MySQL, Memcache, and so on, you get a module in metric bit that interrogates periodically those services and fetches metrics from them. In addition, we also have more generic modules in Filebit, for example, this HTTP module that can be used when there is no support. In case you want to monitor a service for which there is no support, and your service exposes metrics over HTTP. So if you want to monitor Docker, then you can also, there are two options basically. One option is to, in order to get some Docker container information. So there are two options. One option would be to interrogate directly the Docker API, and the second option is to use cgroup. And cgroup reads directly similar information from /proc. The advantage of cgroup is that you can use it to for all kinds of container technology, not only for Docker. But the disadvantage is that you don't get the name of the containers. It sometimes is a bit frustrating. So here is an example. Here is a screenshot of a dashboard, of the dashboard that comes with Docker module in metric bit. And you can see here it gives you some information about your Docker containers. For example, you can, besides the ID of the container, labels that are used, and the name of the container, you can also get the CPU usage, the memory usage, the disk I/O information. You can also get information about the status of your Docker containers, for example, which are running, which are stopped, and things like this. You can get details about the traffic, the network traffic that is exchanged between your Docker containers. What else? You can also, for example, get details about the image that was used when starting that Docker container and things like this. A similar approach is for Kubernetes. So you can monitor, you can get metrics about the running containers and the available pods, but using the Kubernetes module in metric bit. And the Kubernetes module comes with a dashboard like this one. Here is a screenshot. And you can see, you can get information like the name of the pod, or the namespaces, or the labels, or the CPU usage, memory usage, the network I/O, and things like this, right? So as you see, we collect quite a lot of metrics. And I think the most important thing is to be able to have a nice way to visualize those metrics, because everyone likes to see in a UI form, right? A matrix, not a number. So for this, we just released it with Kibana 5.4 time series visual builder that offers you a way to visualize time series, and it's meant to be used with metric bit data. So metric bit, with the data that are generated by metric bit. And I would like to take an example here of how you can use this time series visual builder. For example, here, I want to create a visualization where you can see reads versus writes from the MySQL traffic. So you consider writes all the MySQL insert commands, update commands, delete commands, and the reads are basically the MySQL select commands. So first we define the average of each of these, for example. So let's start with writes, right? So first we define the average of the MySQL delete commands, and then the average of the MySQL insert commands, and then the average of the update commands, and then we do a calculation. And in order to do a calculation, basically you can define a variable for each, and then use a painless script to sum it up. And after we have this calculation, which is the sum of all these commands, then we need to make a derivative out of it. Why a derivative? Because the number of delete commands, for example, is a ever-growing counter. And we don't want to see the total value. We want to see the rate per second. So that's why we need to use a derivative here. And similar with the reads, we define the average for the number of select commands, and then we apply a derivative. And basically the result is this, where we see both on the same chart. Going a bit bad. So this is only a small subset of what this time series visual builder can do. Here, for example, can do top N, can build gauges and things like this. So if you want to learn more about this, there is a cool demo that was done by my colleague Chris during Elasticon. So there is, you can see it online. So your applications and your services are running on different operating systems. So I think it makes sense to also monitor at the operating system level in order to see how your hardware resources are used. And a good way to do that is by monitoring fetching metrics from your system. And we have in MetricBit, we have a system module that gives you information about the CPU usage, memory usage, the load, the disk I/O, file system, network stats, meaning like how much network traffic is exchanged on an interface, and per process information, per core information. And one of the dashboards that comes with this system module in MetricBit looks like this one. So this is built with time series visual builder that I was telling you about earlier. And here, as you can see, you can see all kinds of the CPU usage, the load, and disk I/O, things like this. So on Windows, probably you will be interested in collecting the Windows system event logs, and you can do that with WinLogBit. So now let's go to the network level. So I think it's very important to look at the communication that is exchanged between your applications, your servers. And to do that, you can use Packetbit, that is listening on the network traffic, then decodes upper layer protocols, creates a request with a response, then correlates them into transactions, and then pushes them to Elasticsearch. So this way you can see the communication between, for example, your web server and MySQL and so on. And in case the traffic is encrypted or there is no protocol that we don't have support for that protocol, then you can still see some data about the traffic exchanged. Another way of monitoring your system is using its uptime monitoring. So this means that you can ping a service from outside to check its health. So with Heartbeat, you give a list of hosts, and then Heartbeat will ping them one by one over ICMP. ICMP basically is a protocol that is used by the ping command. Using TCP or TLS connect. Basically, this is similar with you running telnet, hostname, and then port, but it also supports TLS, or HTTP, where you basically specify a list of URLs, and Heartbeat will send a HTTP request to each of these URLs and will interpret the HTTP response. We'll get the response code, and also will be able to look at the response. For example, if you want to match something in the response. Heartbeat is able to create some metrics, to collect some metrics, round trip times for example, for DNS resolve, for TCP connect, for TLS handshake, things like this. And here you can see there's a screenshot of the dashboard that comes with Heartbeat. And my favorite part is heat map here. So on the x-axis is you have time, on the y you have the response time, and each of this bucket is the number of queries that fits in that. So I think this is a cool visualization for visualizing the performance data. So far we spoke so much about what data we can collect using a logging and monitoring tool. And I think what people don't realize is that using another interesting use case that you can have with a logging and monitoring solution is security. So our purpose is to be able to discover breaches using a logging and a monitoring solution. And this as soon as possible, because I think this is what makes the difference between a catastrophe and a minor incident. And next, I would like to go through a few data sources that I think are important to monitor in the case of for the security use case. So first is auth logs. So for each SSH login, you will see this in the authentication logs. And you will see, for example, if there is a user that is trying to do an SSH login, you'll be able to see if he used the password or if he used the public key. And in case he used the public key, you'll be able also to see the public key that he used. also you'll be able to see the IP from where the user tried to log in. And based on that IP, you'll be able to get the location of the user. Okay, so failed pseudo attempts are also important. So this is useful because you want to know when the hackers want to upgrade their privileges using the sudo commands. And also important are when a user is added or when a group is added. So in case there is a user that was created that is not expected, so you'll know to take some action. So one of the dashboard that comes with authentication. So authentication logs is basically part of a module in Filebit. And it comes with this dashboard for SSH login attempts. And I think my favorite is this tag cloud from here, where you can see what are the most usernames that are used by hackers to try to SSH into the box. And obviously, the most used one is root. Using Kibana maps, you'll be able to also see from where those attackers were doing the SSH login. So on Windows, you'll probably be interested in looking at a logon failure event from the security event log, and you can do that using Logbit. And here is a screenshot from the dashboard that comes with that. And here you can see, for example, the logon failures. No, these are the successful logons or the failed logons and things like this. Another interesting thing to look at is this audit D. I'm sure many of you are familiar with this. So it's a daemon that audits every syscall into the Linux kernel and writes the records in logs. It's available since the Linux kernel 2.6.14, if I'm not mistaken, and you can do things like you can see when a user accesses a file, you can see when there are new connections created, or you can see when a new process is created. The disadvantage here is that it creates quite a lot of traffic. And this is because the Linux audit framework creates multiple messages for each auditable event. For example, the rename syscall creates 8 messages for the same event. So I think it will be more valuable if those messages will be correlated together into a single event. So that's why we are now working on an alternative for Audit D as a module in MetricBit that buffers all these messages and correlates it together into one event. The first version is already merged in master, so feel free to try it if you are curious. Okay, so another thing that is interesting to look at is the running processes in order to look for suspicious commands. Right, so you can easily do that with a system module with MetricBit because it shows you details about each process and things like this. Network connections. So here you can see so probably here you are interested to see when a process creates an outbound connection or when a process is in a listening mode, is listening. And this works by pulling the kernel for TCP sockets and then correlating them with the running processes. DNS tunneling. DNS tunneling, I don't know if you are familiar with, it works by encoding some data in the DNS request or DNS response. And the client creates a DNS request to a domain that is forwarded to a malicious entity, authoritative domain name. And then, how do you, so there are quite many ways to track this malicious, let's say, data. Sorry, what I forgot to mention is that when the DNS request reaches the malicious authoritative domain name, then it adds in the DNS response the malicious data. So there are multiple ways how you can track that. And one way that we are doing here is that we are looking for the unique host names that are created for a domain. And there is a, I don't have it a screenshot, but there is a blog post about this. So if you are interested in more details, and you can see more details about this there. So you can detect that with Packetbit. I forgot to mention, because Packetbit has a DNS module that is able to monitor the DNS traffic. So in conclusion, I show you that there are so many data that you can collect. And for example, logs, metrics, events, and so on. And then you have all this data into Elasticsearch cluster. And then the idea is that on top of it, you can have other applications that are using that data. For example, you have some visualizations, for example, Kibana or a different UI that visualize your data. You can do reporting based on the data. You can have alerts. You can create alerts. For example, you want to be alerted when a metric reaches a certain threshold. Another interesting application is anomaly detection. So you can build a path. And but most of these are part of our XPack offering. So it's a commercial. They are commercial products. Yeah, that's all. Thank you for your attention. Here are my slides at this URL. So now, if we have questions, I think I was a bit too fast and I finished a bit earlier.
Yeah, we have plenty of time for questions. So, or if you want to know anything else that Monica can answer, don't hesitate.
Talking about scalability, I wonder what's the biggest installation you've seen so far?
That's quite big. I can't give proper numbers because we have big customers. For example, eBay is using Bits quite a lot, and yeah, in quite big numbers. So I can't give you the exact numbers, but they're really huge. Couple of terabytes every, I don't know. I don't want to give some wrong numbers, but there is quite high. So I'm not sure if I answered the exact question. So you are referring to...
Yeah, I'm interested if you would have, let's say, 10,000 hosts and you would want to implement everything you showed. What size of storage would you need, and when would you run into which problems? Because I can't believe that this would work with that size. Maybe.
Yeah, so the agents are quite lightweight because they are written in Go, so they can push a lot of data. It's up to you to say what data you are interested in, so you can filter at the agent level. And then it's up to Elasticsearch to deal with all the storage. So we have quite big deployments at big customers, and the scalability is on the Elasticsearch side, and I think it's very mature in this sense. So, yeah. I'm not sure, did I answer your question?
So maybe can you tell us something about the future of the Beats project? Will there be any new official Beats coming soon, or what are the plans for the future?
Yeah, so we want to extend quite a lot in the security space, and we also want to exclude so we started with Kubernetes, and we want to also be mature and in the sense that to offer a complete monitoring solution for Kubernetes. We have already a first version, was just merged, I don't know, a month ago or so, the Kubernetes. Then we are not planning to extend our bits, so because we already have quite many bits. So the new things that we want to basically add will be in the current bits.
All right, so I think Logstash is does a part of what Beats already do. So there are some inputs that do the same things that do Beats. So the question is, will Beats one day, replace Logstash? Because currently you can already send your data directly to Elasticsearch.
Yeah, that's a good question. I get this question quite often, to be honest. So we are not here to replace Logstash. Obviously, we are working for the same company, let's say like this. So it's true that in some cases you will need Logstash. For example, let's say you want to send your data to Elasticsearch and also to S3. In this case, you have to use Logstash, right? So we don't want to basically extend our outputs and focus more on collecting the data and not so much in adding more and more outputs, and let Logstash do that. Also, another thing that is worth mentioning is that Logstash has persistent queuing. And I think this is very huge in the sense that now there are quite many deployments with Kafka. And the idea is to use Logstash and don't need to have Kafka in your deployments.
All right, so do we have any more questions? Otherwise, I would have one more. So is there any attempt to somehow create queues in Beats? So like when something's blocking, to actually queue the events on the client side?
Yes, so we are working on a solution, hopefully for the next major release, 6.0. And we call it spooling to disk. So it's important because in case, for example, Logstash is down and we cannot send the events, so we can, do a bit of buffering on our side.
Right,
so yeah, that's.
So you mentioned version 6.0.
Yeah, but
when will it come?
Yeah, usually we don't give dates. Or we don't promise anything because we are trying to make it as soon as possible, and if we don't make it, then we have the freedom to say that we are postponing for the next release.
All right. Thank you very much, Monica.
I think he had a question, if we have time.
Sure. Sorry.
One question regarding the visual builder. Is it
About
possible?
What?
The visual builder in Kibana 5.4, is it possible to use different time series databases, or is it just for Magic Beat?
Yes, you can use, it's working on top of Elasticsearch. So any data that you have as a time series, it's in Elasticsearch is working. So I said for Metric Bit because in order to encourage people to use it together with the metric bit data. But it can be used for any kind of time series that you have. But it's tied to Elasticsearch.
Do we have any more questions? All right, Monica, thank you very much for being here.
Thank you very much
you
for
for this talk.
inviting me.